Okay, I'm going to attempt, keyword attempt, to show you how to take the FastQ data from uBiome and process it to an independent provider and get results. I'm hoping to remember all the steps I did before, so there may be a few hiccups as we go along. So as a starting point, go to Explore My Microbiome, hit Advanced Data. Well, we logged out, okay. And select the sample you want to work with. For example, let's take a look at this sample. Then we go over to downloads. Downloads are all sequential data. After a few seconds, you'll be prompted to save it. And we are prompted to save it. I create a folder called walkthrough, and that's where I'm going to save it. And say yes. So we now have it saved. Let's go over and look at the folder. The folder is a zip file, and what you need to do is actually open it up and extract all the files, which is what I've done here. Double click here and we see each of the files involved in the zip. And you notice that we're not dealing with 10 megs of data anymore. We are dealing with 10, 20, 30, 40, 50, 60, 70, 80 megs of data. So the file is getting bigger and bigger and bigger. Now, if I take a look at the contents of one of the files, you find that it's all Greek, and that is because even though it's a big file, the file is compressed. So we could attempt to do a extract here, and there we have the contents of it. And now we have the little 8 meg file become a 64 meg file. So what we are now talking about is we have 8 files. We have the one zip with 8 files. Each of the 8 files expands to 64 megs, which means we have in total 8 times 64 megs, we have 500 megs, half a terabyte of data. So we are talking about big data. Let's do a quick edit of the data. And here's what we have. And what we have here, for those of you who are literate, is a DNA sequence. So what we have is we have a variety of different DNA sequences, and these DNA sequences are what is being matched up to determine which bacteria is involved. Half a terabyte, 500 megs of data is involved. So it gives you a slightly different perspective of the services that they are offering. Next, we hop over to the site which we are going to use for the first run through, megagenomics.sequentialbiotech.com. You need to register to make use of it. Once you have, you can either log in, or since I'm already logged in there. And we see how much user storage space is being used. We have, for my first pass through, we made use of 40 megs, which means basically when we upload stuff to them, we are only using the space of the compressed zip file. You can see that it's a EU site. You have a wallet. If you exceed the 2 terabytes of data, which they grant for free, which is sweet, thank you, sir, thank you, appreciate it. You can now proceed to do it. I have some academic credentials behind me, so I managed to get in under the academic prescription. So let's proceed to upload the samples. First thing we do is we select the samples which we want to upload, and we have them here. Here are the 8 samples. You notice there's L1 and L2, L1 and L2. These are paired samples, so let's go and proceed with those. And now we proceed to do a upload, and this will take a few minutes. And what will happen in the meanwhile is they will send you emails at each critical spot. They will send you an email saying validation will start. Some cases for commercial users, it may well take a couple of hours for them to upload and process and validate the data. Validation means making sure that you only have DNA letters in the sequences, etc. So everything tends to be time consuming. Remember, they're going through 450 megabytes of data, making sure everything is good. Once they have finished doing that, then we will get an email stating the validation has finished, and we can now go on and do processing from there. If you stay on the page, what you will find is occasionally a message shows up in the top right indicating processing has finished for one of the files. And we almost have another file finished being transferred. And once it's finished being transferred, it has to be verified to be accurate. That is, has no invalid DNA sequences to it. And then we'll see the magic completed, and it will go on to the next one. And our last sample just finished. So we now go on and click to validate, and we need to select how we could validate it. The different choices I'm going to leave for people to dig in themselves. The purpose is to show how to do it, not to explain the ins and outs. So we click that, and we see validation process has started, and time for another coffee break. And at this point in time, I think we actually have to press the start validation button and click I understand. Whoops. Okay. Nope, we don't. So it was misleading button. Okay. And what we do is we have our existing files pending validation. So we wait until we get the email. Okay. Back to coffee time. After a few minutes, you will see this magic purple line going across, so that indicates we're making progress. Be patient. Hey, good news! It's finished. And now that you're addicted to coffee, let's go on. So we proceed to start using the first samples. And now it asks us, is this going to be professionally used or is the free tier? Of course, being cheap, I'm going for free. And so we go and we mark them all as free. And then we go and confirm and pay. We place the order. And now we proceed to go ahead to create a new analysis. And what we now do is give a name for it. I'll call this one a walkthrough. And we select this one, and notice the reason is the data is existing as data. The other two are different types of data analysis for DNA. They don't apply, so we need to make sure we select that one. And now we end up having to pick which one we are going to use. I'm going to use the Illumina because it's what we had validated against. And we proceed now to click Next. And we now proceed to go down the list and check painfully. Doesn't always check the ones which we want. Excuse my jumping around all over the place. And we have added our samples. And we now click add the selected files to a condition. And we have the files and condition. We go to click the condition, ME CFS walkthrough. Oops. ME CFS walkthrough. So far, so good. We click next. And we want to use the 16S. Again, reading on the right, you find some use 18S. And this is a mixture of 16 and 18, but what we really want to do is use 16S because that's what the source is in. And we click finished. And now we are waiting for creation to happen. So analysis has been created, and now we're just waiting once more. Time for more coffee. After about 2 to 3 minutes, I suggest you click refresh. It won't automatically refresh the page. And now you have it completed. And we have the walkthrough, and we see that it took about 11 minutes, 12 minutes for it to process it. So this is a cup of tea or cup of coffee inclined process. Or alternatively, if you can drink it, good glass or two of wine or a beer. Okay, let's go on, and we'll proceed to click completed. And we now have all the information sitting down there, and we have the taxonomy, trim quality analysis, and detail. So I'm going to download each one of them, and we're going to take a look at what the contents are. First, we're going to download the details. Okay, so we have the bar graph, we have all sorts of stuff, we have fast filtering, we have all sorts of information, and we have all that information sitting there. And I'm going to go back there, and we also have the details ones. And gives us all sorts of more technical information about quality, base sequence, and everything else. And I'm looking for a particular file which you did last time. So under details, we actually have a bunch of charts very reminiscent of uBiome. And what we have here is for each one of the samples, we have the relative numbers. Now you notice they jump around, and the numbers vary a bit. Sometimes you have the percentage jumping back and forth between the two. And that is because the passes will sometimes pick up slightly different things. And we can go down and we can take a look at everything from all examples and proceed there. We have the detail information here. We have more detail here and here. And then we can actually go on to look at the classes. We have the class information here. Again, some variation from each pass. One of the realities. We have the ordering, and we tend to sort of, you notice it tend to be 4 goes one way and 4 goes another way. And we could go and click on a particular one, and we get more information there. Families. We have, again, the same type of information which we'll have with uBiome. You have the option of saving as CSV, and It will download that information for you to make use of separately later. We have the genus, and you see all the details. And if you go down here, oops, let's go down. And of course, our old friend E. coli is not listed there because that is a problem with the 16S, but we have a whole bunch of other things there, 19 different genus down the species level. We have a long list of species. I notice we have a whole bunch, 70%, which are unknown species. So we get to see the unknown species here. So, and we have a number of reads. We have all sorts of technical information, which I am not about to go through and explain to you or attempt to explain to you. So we now have successfully processed through, managed to get the information processed, and we have our information ready. The stuff is on screen, but you want to have a machine readable format. It's available. I need to show you the little trick of finding it. It's sitting over here in project file. We have three things. If you double click here, you'll see a file there, and you can basically just click that and ask you to download it, and we'll put it in the same folder. We have the trimmed file also, which contains of all of the trimming information, technical stuff. And we have the source file, which again, which we already aware of, and which we uploaded. So we have this lovely little tar file GZ, which is a Unix style compression file, which you usually need to use something like Win7up on a Windows machine to do it. I believe it's built in the Mac. Okay, so let's go over and take a look at this file. So right here in the same folder I was working, we have the tar file. And what I'm going to do is double click it because I have Win7 installed. It brings up what the file is, and this is the file here, so I'll select that. You now see all the files in it, and we can click it, extract all. It will ask where, and web. I'll create a new folder called web, and we'll pop everything in there, and select folder, and 44 files are extracted. We close that. We can now close WinZip or Win7up. We're going to web, and we have a whole bunch of files. Some is text, some are HTML file, etc. So let's take a look, and the items with the word count is quite interesting because when you open it, you'll see the actual counts from each one of the passes. Remember, we have 4 separate passes of the data. Okay, I'm going to go and open Excel. So I have Excel open. I'm going to do File and Open. And we're going to look for it, and we are going to browse, and we are over on my D drive, and we at walkthrough, web, and we have the HTML file, and what we're looking for is text files, and we have classes count. Double click that. It says delimited by commas is what it is, and we click next. Everything line up nicely, or actually it's delimited by tabs. We can next, and now we basically do a finish. And now we have all the data sitting in Excel very nicely. And what we can do is do all sorts of fun things. Like, for example, we can do a sum of each column, find out how much we get in each. And we can do a cross sum if we really want to be gluttonous. And so we have, taking everything together, we have 770,000. Now comes the question of what do we do with the disparity in the numbers? 22 to 168, 173, etc. My general suggestion is we probably want to, for purposes here, we don't know exactly what uBiome does. It just simply takes the average. Oops. Okay, actually, let's do the sum. Just as easy. And we'll copy that all the way up. And we go and mark this as a, as a name, which is total. And now I simply go up here and do that divided by total. And we go down. And now I can go and change it over to percent if I feel like it. And we'll add a few more decimal points. Oops. So now we have percentage of each. And we're going to do that for each and every one of the layers. Down the species level, you remember we saw a rather large percentage of unknown species. At this level, we have 3% of unknown. Let's do one more import, and we'll open up, and we'll go down to species count. Again, it's tab limited. We just go through, we click finished. We have a lot more here. And we do equals sum. And excuse my clumsy Excel skills. And we have the sum there. And we go across. And we're going to now do a sum across here. And we have the same number, which is to be expected because of the decomposition of in the hierarchy. And we can again do the same thing we did, except we'll call this particular one species total. And we do equals that divided by species total. Copy it all the way up. And convert to percent. And then add a couple more decimal points. And we now have a nice detailed information about everything. And what is important to notice is that at the species level, we only identify a bit over 28% of the strings, of the species. And of course, strange would be even smaller number. So it becomes interesting walking down to see where our current state of knowledge stops and where it goes. At the class level, we are at, where it's unknown, we have 3%. Let's go and just for completeness, do one more And we're going to do that at the family level. Actually, let's do the genus level. And we'll just do a quick finish. We have everything there. And we have, of course, a lot more than we had before. And run across. And then we'll do a cross sum. Same magic number. And now we go and copy it all the way up here. Change percentage. Add a couple of decimal points. Oops. Forgot to do something. I forgot to define a name, and the name would be genus total. And so that's actually, we're going to unnumberize it. And in the next column over, this is the total column, we end up doing whatever just count is divided by genus total. And we now do all percentage and number across. And when we get to genus level, whoops, I forgot to do the magic. We find we have 32% are unknown. So as we drill down from classes, we get a small percentage. When we get down to genus, we get a bigger percentage, and we're just 32%, almost a third of your microbiome, which we cannot even name at present. Something to consider. It means that there may be significant players out there which are anonymous. So we wait for the next little bit of joy for science to advance. At the moment, we get a pretty good idea down to certain levels, and we identify some of the next levels down accurately. But once we get to the genus level, we start running out of a high degree of identification. We identify 68%. When we go down lower, it flips around. We barely identify 30%. So we need to be careful about assuming that we know more than we know. Wise man knows how little they know. Okay, at this point of time, I think I'm done. I've done a complete walkthrough, including showing the data in Excel. Go explore, play with it. It should be good. Have fun.